Let us solve the integral of secant to the power of 6 of x. When dealing with either an integral of secant or a cosecant and your exponent has an even number, the first thing that you're going to do would be to factor out 1 secant squared. Thus, this makes this secant to the power of 4 of x multiplied by secant squared of x and copy the rest, which is dx. The next step would be to transform the remaining terms into its trigonometric identity, wherein secant squared of x would be equal to tangent squared of x plus 1. Since what we have here would be secant to the power 4, and what we need here would be secant squared, just condense it, which makes this the integral of secant squared of x raised to the power of 2. Know that this is simply equal to this one, and copy the rest. Now that you have secant squared x here, we can transform now. Next step would be to expand this expression. The general formula for this would be a plus b squared would be equal to a squared plus 2ab plus b squared, wherein a here represents tangent squared x and b represents 1. With that, the expansion of this would be equal to tangent to the power of 4 of x plus twice of a here is tangent squared x and b here is 1, so this is simply 2ab, and b squared, which is 1 squared, it is equal to 1, and copy the rest. We can see here inside the parentheses we have a lot of tangent, so we can actually use u substitution here for simplification. Let u here be just tangent of x. Whenever you're doing a u substitution, take the derivative. The derivative of tangent of x would be equal to secant squared of x and multiply it by dx since it is respect to x. And isolating dx, putting secant squared of x to the other side, it would be equal to du all over secant squared of x. By that, we can now substitute the value. This would be the integral of tangent to the power of 4 would be equal to u to the power of 4 plus 2. Tangent squared of x would be u squared plus 1 multiplied by secant squared of x, and dx right here would be equal to du over secant squared of x. You can actually see here that secant squared x would cancel each other out, which will leave you with this expression. Now that you have that, you can now simply integrate the parts one by one using a power rule. The integral of u to the power of 4 would be u to the power of 5 over 5 plus 2 multiplied by the integral of u squared, which is equal to u to the power of 3 over 3, and the integral of 1 du would be equal to u, and add the constant of integration. And for your final answer, you can just simply put u back into its original form. We can rewrite this first as 1 over 5 multiplied by u to the power of 5 plus 2/3 u to the power of 3 plus u plus c. And now by reverting u back into its original form, we would have our final answer as 1/5 tangent to the power of 5 plus 2/3 tangent to the power of 3 plus tangent of x. This is all tangent of x, I mean, plus the constant of integration